We will now talk about how to find the domain of a function given a graph. The domain of a function, remember, are all the x values that when you substitute into the function, we get an answer back. And the answer back will be in the range or our range value. So the set of all x's that define the function are its domain. Well, looking at this graph, first we'll look at x squared minus 3x minus 4. And that's a parabola. And we lay the graph flat on the x-axis. So you pretend the graph is a piece of wire, not a rubber band or anything stretchy. Just flatten the graph as a piece of wire onto the x-axis. So we push this down to the x-axis. The question we ask is, what part of the x-axis is covered? Well, when we do that on this example, you see that the whole x-axis will be covered. There's nothing left that isn't used. All the x values will be used in this graph if we take this graph again and flatten it to the x-axis. Everything's covered. So the domain in this case is all real numbers or negative infinity to infinity. The range is a set of all y values that are matched with the x values. So this time, again, we'll pretend the graph's a piece of wire, but nothing stretchy, so not like a rubber band, just wire. And we'll straighten it and lay it vertically on the y-axis. So you pretend that the graph is closed between two elevator doors. So we look at the graph. We had a U-shaped graph, and we're going to press it against the y-axis like it's in an elevator doors. So look what part of the y-axis is covered, and we see that it's from 1 up. Our range is 1 to infinity. Now we include 1, so we use a hard bracket, and it goes forever. So we use infinity. So we go low to high. In the next example, if we flatten the graph to the x-axis, we see that only a portion of it is covered, and this point's -5 and this is 5. So the domain in this case, since -5 and 5 are included in the graph, is going to be from -5 to 5. Only that part of the graph, or the x-axis, is covered. When we do the range, we smash it to the y-axis or push it to the y-axis, and only a certain portion is covered from 0 to 5. Nowhere else is covered. So again, we do 0, 5 inclusive, and because those points are included, 0 and 5 are included, and we can think of that as low to high. In the next example, to find the domain, we flatten the graph to the x-axis, and notice some of the x-axis is not covered. To the left of -3 is covered, and to the right of 3 is covered. Look at the x-axis. Again, it's flattened. The left of -3 is going to be part of the domain. Then it's skipped. There's like a hole in the x-axis, or a space. And then from 3 to infinity will be covered, and these points are again included because they touch the x-axis. So our domain here, reading the graph from left to right, is -infinity to -3 inclusive. Then we jump to 3, which we include 3, and it goes to infinity. Taking it over to the y-axis, it looks like every y will be accounted for. So this whole y-axis will be covered. So our range is -infinity to infinity, or all real numbers. Let's look at this last example, pushing this graph as it is a piece of wire up or down to the x-axis. If we lay this graph flat, so pretend we take these ends and push it down to the x-axis and push this bottom part up, it's going to cover the whole x-axis. There's no spaces or gaps or holes. So our domain is all real numbers, or negative infinity to infinity. To find the range, you take it over to the y-axis, and the part below the graph is not going to be covered. So if we look, the graph is going to be covered starting here on the y-axis, and that's at negative 5, and then it's going to be covered the rest of it up. So low to high with no breaks is going to be from negative 5 to infinity. So the lowest it goes will be negative 5, and the highest it goes is infinity with no breaks. There's nothing below negative 5. So again, you think of that graph as a piece of wire, and you push it over to the y-axis and ask what part of the y-axis is covered. That is our range.